Good afternoon, everyone. Myself Asha Bhavani, working as an assistant professor in CSE A and ML department in Marri Laxman Reddy Institute of Technology and Management. My topic is Introduction to Java Programming Language. In this, I'm going to discuss about history of Java first. Java programming language was developed by a scientist called James Gosling. Along with James Gosling, there are other two scientists. Those are Mike Sheridan and Patrick Norton. So these small group of people, they used to call it as Green Team. So these are the Sun engineers. So initially they developed this programming language under Sun Microsystem. Initially they developed this programming language for the sake of embedded systems. This programming language is used in electronic devices called set-top box, remote, TV remotes. So in these devices, televisions, in these devices, they used this programming language. Initially, they have given a name to this programming language as Green Talk. Green Talk is the programming language name which they have given in the initial days by the James Gosling. And initially, this programming language is saved with .gt extension. This programming language has saved with .gt extension. Later, they have given name to this programming language as Oak programming language. Why they have chosen this programming language name as a Oak programming language name? Because Oak is the name of a national tree of a developed countries like France, USA, Germany, and Romania. For these countries, the national tree is oak. So as a honor given to those developed countries, they have chosen the name of a national tree as a name for the programming language. Later, they have changed this programming language name from oak to Java in 1995. So how they have chosen this name Java to this programming language? There is a separate story behind this. So that is when James Gosling and his team, when they're developing this programming language, they used to consume lot of tea and coffee they used to consume. And the world's best coffee beans has been produced in an island. That island name is Java Island, right? So this Java Island is there in Indonesia. So in this Java Island, so they used to produce world's best coffee beans, right? And these scientists, James Gosling and his team members, used to consume lot of coffee. Because of consuming this coffee only, they used to develop this much effective programming language. So they thought in that way, and they have chosen that island name Java as a programming language name. So this is how they have chosen the name for this programming language as Java. It under Sun Microsystem, they have developed this programming language initially. Later, a significant milestone is occurred on November 13, 2006. So here, a complete large portion of this programming language has released as a free and open source software in the market, right? Later, this programming language, Java programming language, has been acquired by Oracle Corporation. Initially, it was under this programming language was maintained and developed under Sun Microsystem. Later, they have acquired by the Oracle Corporation. Even till today, this Java programming language is under the Oracle Corporation. So this was the history of a Java. Next, if you see the differences between procedure-oriented programming language and object-oriented programming language. So now we'll see the differences between procedure-oriented programming and object-oriented programming language. So under procedure-oriented programming language, so like C, C++, C, Fortran, Pascal, all these are procedure-oriented programming language or functional-oriented programming language also we can say that, right? And now we'll see the differences between procedure-oriented and object-oriented programming language. Under procedure-oriented programming language, the entire program is divided into a small parts called function. So the entire program is divided into a small parts called functions. Whereas in object-oriented programming language, the entire program is divided into a small parts called objects. So in case of procedure-oriented, the program is divided into functions. In case of object-oriented programming, the program is divided into a objects, right? And next, procedural programming language, it follows the top-down approach, whereas object-oriented programming follows the bottom-up approach. So how can we say that procedure-oriented programming is a top-down approach, whereas object-oriented programming is a bottom-up approach? If you see the structure of a C program, first we'll write the first line of the C program is int main. We'll write the main function. We'll write the main function. Inside the main function, we'll write different types of functions and variables we will write, right? So the execution of the program starting from the starting line of the program. The starting line of the C program starts with int main method. So the execution also, it will start from the first line of the program. So that's why we can call this procedure-oriented programming is a top-down approach. But when you observe object-oriented programming language, if you see that the program follows the bottom-up approach. So what is bottom-up approach? Bottom-up approach is nothing but, so how we can write a program in the object-oriented programming language. First, we'll start with class. Let's say that the class name is A. Inside the class, we'll write some functions. We'll declare some variables. After that, we'll write a main method, that is public static void main. Inside of this main, we have string array arguments. Inside of the string main method, so we'll create object, we'll invoke variables, and we'll invoke methods. All these things we can do inside of this main method. So after we can close the class. So this is how the structure of a Java program in this language. So in this, how the program is executing, the program will start executing from the main method. Inside the main method, we'll create an object for this class, like with the help of a new keyword. So the structure of how we can create the object, what is class, what is object, that we can see in the upcoming classes. So with the help of this object only, we will access the functions. We can access the functions, we can access the variables, all these things we can access. So the execution of this object-oriented programming language, it will start from the main method, which is placed at the last of the class, right? So that's why, so the execution will start from bottom to top in case of object-oriented programming language. So that's why we can say that object-oriented programming follows a bottom-up approach, whereas procedural programming follows a top-down approach. Next, there is no access specifiers in procedural programming language. Access specifiers are nothing but like public, private, protected, default. All these are access specifiers, which with these access specifiers, we can control the accessing of data from one class to another class, from one file to another file. We can control the accessing of data, right? But this opportunity is not there for procedural oriented programming language. These access specifiers are available for object oriented programming language. So this is one more difference. Next, operator overloading is not supported in procedure-oriented programming, whereas operator overloading is not possible in case of procedure-oriented, whereas object-oriented operator overloading is possible. Next, in case of procedural programming, there is no concept of data hiding and inheritance. So data hiding inheritance concept is not available in procedure-oriented programming, whereas in object-oriented programming language, this data hiding concept and inheritance concept available, right? With this, we can reuse the code. Code reusability is possible, and we can provide the security. We can hide the unnecessary details or important details from the customer. So these two things we can achieve in OOPS concepts, which is available in object-oriented programming. Whereas, see, the same thing we have in the next point. Code reusability absent in procedural programming. Because this code reusability is possible with the help of data hiding and inheritance, but that concept is not present in the procedure, so it is not available in procedure-oriented programming. So next, examples for procedure-oriented programming is C language, Fortran, Pascal, Basic. All these are the examples for function-oriented programming or procedure-oriented programming. So the examples for object-oriented programming are C++, Java, Python. All these are the object-oriented programming languages. Next, we have several features of Java programming language. In that, we'll see the first one. Object-oriented Java programming language is very simple language. Why? Because the syntax of C language and C++ language is similar to the Java programming language. So that's why it is easy to understand, easy to learn. And next, here we have Java has removed many complicated and rarely used features like explicit pointers, operator overloading. Explicit pointer concept is present in C language. Operator overloading concept is available in C++. But from C++ to Java, they have removed operator overloading. From C to Java, they have removed explicit pointers. So these two concepts has removed in Java. So due to these reasons, we can say that Java is a simple language. Next, Java is a object-oriented programming language. So why we can say that it is an object-oriented programming language? In this, everything comes under object. Everything is based on the object. An object is a real-world entity. Inside the object, we have information and data. Every object is represented with some information and data. If collection of data is arranged in a meaningful way, we can call that as information, right? So as I have shown you the previously, in case of differences between object-oriented and procedure-oriented, there I have written a small program. See, if we have a class, for example, the class name is student. Student is the class name. So inside this class, what I'll write is some data members. I'll write some data members as well as member functions. Data members and member functions we can write inside the class, right? So, and inside this class, we also have a main method, public static void main method we have. Inside of this main method, we can create an object. We'll create an object for this student class. With that object only, we can access this data members and member functions. For example, student is a class, right? And whereas object is what? For example, every student has their roll number, name, right? Subject. All these are we can consider under data members, like student roll number, student name, right? Student subjects, student subject. All these are what we can call it as data members. So this data members we can consider it as a data, right? And next, member functions. Member functions are nothing but the actions. So what type of action can be performed by the student is student can read, student can write the exam. So these are the functions which can be performed by the student. So this data and functions together can be accessed with the help of a object. So object is created for each and every class. So we create object for the class. With that object only we can access this data members as well as member functions inside the main method, right? So next, platform independent. So here object is a physical entity, whereas class is a logical entity, and an object is an instance of a class. Next, Java is a platform independent language. Java is a platform independent language means write once and run anywhere. If you write Java program in Windows operating system, if you develop a Java program in Windows operating system, Java source code, right? So here we can run the Java program, we can write the Java program and compile the program. So when we compile the program, here a bytecode of this program is generated. So this bytecode we can execute in different operating systems like Unix. In Unix operating system, we can execute. In Linux operating system, we can execute. And in Mac operating system, we can execute. So the bytecode of the Java program can be executed in any one of the operating system, right? We need not to develop the Java program again and again whenever we change the platform. So that's why we can say that Java is a platform independent program, right? So next we have Java is architecture neutral. So Java programs never communicate with the platform directly, right? So for example, initially I developed a Java source code. In Windows operating system. In Windows operating system, the system configuration is, let's say that 32 bytes. The operating system configuration is 32 bytes, right? But after a few months, I have updated my operating system. I have updated my operating system to 64 bytes. Same operating system. Let's say that Windows only, but the configuration has been changed from 34 bytes to 64 bytes, right? So now I can execute this bytecode of this Java program even in this 64 bytes operating system, right? So the source code or the bytecode of this Java program cannot depend on the architecture of the operating system. That's why we can say that Java is a architecture neutral. Next, it is portable. So why we can say that it is portable? We can carry this Java bytecode to any platform. Once we develop it in one operating system, we can run it in different operating system. So it is portable. Next, secure. Java is secure. Why we can say that Java is secure? Because of absence of explicit pointers, right? So what is the advantage that we have if there is no explicit pointers? Means generally explicit pointers is nothing but it has the address of a variable, right? If we can access the address of any particular username or password, we can get those details easily. So with this explicit pointers, there is a chance of thefting the data, right? So that's the reason why they have removed this explicit pointers in Java, right? Next, one more reason why we say that Java is more secure means, so inside the JRE, the Java Virtual Machine, so inside this JVM, we have a sandbox. Sandbox is present. Inside the sandbox, with the sandbox, what it will do is, before it execute any bytecode of Java program, first it will check whether that source code can be developed from a authorized resource or not. If that source code, the bytecode of the Java program has not developed from an authorized resource, then it won't execute, right? So this kind of checking will be there inside the JVM with the help of this sandbox, right? So due to there are several reasons. These two are main reasons why we can say that Java is secure. Next, Java is a robust language. Why we can say that Java is a robust language? Because it is strongly typed language. It is strongly typed language and have a good memory management, and it has some inbuilt exception handling mechanism. So how we can say that it is a strongly typed language? Because we can check the compile time errors. right? After we write the Java program, let's say that a.java, it is my source code, is my source code. So this source code is going to be compiled with the help of a compiler. So this compiler will generate a bytecode. This compiler will generate a bytecode, right? So like what is this bytecode name? A.class file is generated. The compiler will generate the A.class file. So this A.class file will be given to the JVM. So the JVM will execute this A.class file, right? So at the time of compilation, the compiler will check the compile time errors. The compiler will check the compile time errors. All types of syntactical errors or typing mistakes has been recovered at the time of compilation. So that's why we can say that Java is a strongly typed language. Next, why we can say that Java is a strong memory management? Because of having automatic garbage collection. Automatic garbage collection means inside of this JVM, there is a garbage collection. So this garbage collection, what it will do is whatever unused variable, unused data, unused reference types, whatever it is there, it would be the memory for those unused variables has been removed automatically by the JVM, right? So due to that reason, we can say that Java has strong memory management. Next, it has some inbuilt exception handling mechanism, right? Whenever we run the program, there may be a chances of having abnormal termination, right? Due to this abnormal termination, the program cannot execute properly. So to avoid such kind of situation, they have introduced exception handling mechanism, right? So these are the several reasons we can say that Java is a robust language. Robust means strong. Java is a strong language due to these several reasons. Next, we can say that Java is a distributed language. Why we can say that Java is a distributed language? Because we can able to access the Java file in a remote area. We can call the methods of Java files from in a remote area over the internet. This kind of feature is available for Java. That's why we can say that Java is a distributed language. Next, Java is a multi-threaded programming language. Why we can say that Java is a multi-threaded programming language? So here, what is thread? A thread is a separate program. It's a piece of code which can be executed concurrently. For example, if we have 10,000 lines of code for a Java application, in this 10,000 lines of code, first 5,000 lines of code is independent on next 5,000 lines of code. So the first 5,000 lines of code is not depending on the next 5,000 lines of code, right? So in this case, what we do is, if we are not applying multi-threading, all these 10,000 lines of code will be executed line by line, line by line, line by line. So it will take a lot of time for the execution of a single Java file. So what they will do is, with this multi-threading concept, they have grouped the independent code of lines into a single thread. So here first 5,000 lines of code is independent, means not depending on the next 5,000 lines of code. So that's why they'll make this first 5,000 lines of code as a thread 1, next 5,000 lines of code as a thread 2. So these two threads will be executed concurrently. So thread 1 will execute as well as thread 2 is also executing. Both threads, that means entire 10,000 lines of code will be executed parallelly, right? With this, we can increase the performance of the Java application with this concept. And all these threads will share the common memory area, right? Due to this reason, due to this advantages, we can say that Java is a multi-threaded programming language.